What we're going to be doing is starting graphing, and I want you, before we get into all the rules and all the little things you're going to be learning on how to graph, we've already done a little bit, but remember that graphing is basically used for predicting. It's all about predicting and seeing what you can do without, with a little bit of information, what can you predict that's going to happen in the future. Now, there are people that get paid a lot of money that can do this really well. You can predict, like, stock market, what happens based upon what's happened already. They can do a lot of data manipulation and graphing, and they can more or less predict what's going to happen, and they bet a lot of money on it, then they make a lot of money. So this idea of predicting what happens, or finding an answer to a question in an easier way instead of like listing a bunch of numbers, is actually a very valuable tool for pretty much any industry. It could be something as simple as how long will it take me to pay something off. Okay, we can answer that question, but we can also come up with a graph to represent it also. So I'm going to start off on number 3, and we're just going to go through, do some basic graphing. I'm going to give you a lot of pointers about graphing as we go. Just an introduction to make sure we understand everything. The first thing, which is often overlooked, is just making sure you read the question. Some people that say they struggle with word problems don't bother reading every single word in order, and they say they don't get it. It's like, well, yeah, you're not reading the full question, so it makes sense you're not going to understand what the question is. So make sure you read them all the way through. Zoe's grandmother put $20 in the piggy bank on the day of Zoe was born. Each year after, on Zoe's birthday, grandmother deposited $20 more. Represent the relationship between Zoe's age, X, and the total amount in dollars in the piggy bank, Y. Now, looking at that sentence and the way it's written, what is the most important piece of information there? And what gives it away that it's the most important piece of information? There's something that's trying to pop out and tell you something. Take a look at it. What's the most important piece of information? How do you know that? Simpler than you think. Yeah? Almost. Something more obvious, though. Something that it's trying to make this more emphasized than everything else, just by how it's written. How about the part in bold? Yeah, they're trying to say that's more important. That's why that part is in bold. Okay. Make sense? So when you see something in bold or underlined or italicized, that's probably where you want to focus on and maybe even start. Okay. So before we start talking about how to solve a problem, how to graph something, it's very important you kind of follow their guidelines. They're saying they want Zoe's age to be X. And so when we're making a chart, we have an X column, we have a Y column. For graphing, we have an X-axis, we have a Y-axis. If we don't say from the beginning what should go on each axis, we don't decide that all together at the beginning, well, someone could decide, well, I'm going to put age here, but the next person can decide to put age on the Y-axis, and at the very end, nobody has any graph that matches because we all made different decisions. So this is actually where we want to begin. Now the label is age. It says Zoe's age for X. What is the units used for age here? So this is called the label. That's what the label is. And usually that's capitalized. It's the same thing like any science like experiment. You're trying to measure something. The same thing you would do. The part in parentheses is usually the units. So how are you measuring? What are we using to measure age here? So read through that. What are the units of age? Or maybe you don't have to read through it. How do you measure age? You measure it by minutes, seconds, years. So you probably put YR for years. You always want to put a label, and then how are you measuring that? What are you counting by? Is another way of saying units. What are you counting by? Okay. What about for Y? What does it say to use? Total amount. So you write out total amount. And believe it or not, this is a point. These are points on their own, like on tests and quizzes, just to make sure you label everything and put your units. There'll be people that say, well, if that's too much writing, I'm going to abbreviate it, and then we mark it wrong and say, no, don't decide that this is, one way, but I'm going to make it my other way just for me. Just write it out, make sure it's very clear. Your purpose here is communication, not to be a minimalist and put as little as possible. You want to communicate as much as possible, so the more you put, the better. Okay? It's hard to put too much information. It's very easy to put too little. All right, so that's really step one, just making sure you follow the directions that you're given. Okay? And it's okay, like for money, just to put the dollar symbol. You could write out the word dollars if you wanted to. Okay, so far so good. Now let's fill out this table. Where should we start? Okay, so one thing that may or may not be obvious is that someone just said that the day Zoe was born, you have to kind of figure out, well, that's age 0. It's not going to say at age 0, $20. It might say on the day it was born. Put $20 in. You have to translate this. And every problem is going to be a little bit different, but they're going to have some sort of indication of, okay, here's where you begin. So one thing about word problems is you can't just memorize the exact same language and expect to see that exact same language in the next problem. On this one, it could be, oh, the days it was born, that's age 0. Next problem is going to be something else, but there's similarities. Okay, what goes next? Let's see here. Year after, so how old would that be? Yeah, so a year after, we have to know, well, year after age 0 would be age 1. It doesn't say at age 1 this happened, it said a year after. Again, you have to read the question to get this information. Now, how much money would be, remember this is total amount. How much would be in year after 1 year? 40. Yeah, some people would say, but well, they put in, isn't this 20? Isn't this how much you're putting in? And no, that's why we had the label. This is the total amount. So we put in another 20, so that's why we're at 40. All right, what goes after that? 2. Now, you can tell as soon as you start getting the pattern, that's how you can predict. And you just, as soon as you figure out the pattern, complete the graph and complete the chart. Fill them all out. So the idea is to get enough information so you can figure out a pattern and then just go with it and fill the rest out. We don't have to maybe read any more of this. We kind of got all the information we need. It might even go through like after 3 years and 4 years, but at some point you can find a pattern and just finish it up. And a pattern by definition for these is simply this. This is going up by 20. This is going up by 20. And you can kind of see, well, I can keep doing that, going up by 20. Okay. And of course on the other side, this is going up by 1. Okay. It's important that these go in the same increments. If not, then it's not going to be a straight line. The fact that these are going up the same amount on both sides let us know, without even graphing it, that it is linear. That's what you call that. It's a line. All right. If you haven't already, go ahead and graph this. We spent last week plotting points. Let's plot them. 0, 20. What do you predict the graph will look like? 1, 40. 2, 60. 3, 80. 4, 100. And just like we went up 20 on the y-axis, and we went up 1 on the x-axis, we can do the same thing here. We can go up 20 from 40 to 60 is up 20, and to the right 1 from 1 to 2. And let's go ahead and label these on the graph. Let's put dollars here, and let's put age here, and age in years. So we're not talking about 1, 2, 3. We're talking about 1-year-old, 2-year-old, 3-year-old. We're talking about $20, $40, $60. We're talking about something realistic, not just numbers. So yeah, for every $20, we get 1 year older. We go up $20, and we get 1 year older. That's how you want to interpret that. And even though our table's full here, you can probably continue it anyway, just like you can probably continue it up here. So going down here and saying, oh, it's 5 and it's 120 is the same thing as just continuing the line here and going up $20 more for another year. Going up one more year and going up $20. And we can continue that. And we're going to have this thing called rate of change or called slope, which is basically what we just did. Using these numbers here, the fact that they're the same all the way down, okay, it means it's going about the same increment every single time. So we usually put the y's on top because this is actually how we think, and the more you graph and see graphs, you realize it's smart to do it this way. So we usually put, well, how much are we going up on the y's? We're going up 20. And how much are we going up on the x's? We're going up 1. So we put the y's on top, the x's on the bottom. And don't forget that this, what does this 20 actually stand for? Okay. Dollars, right? Because it's on the y-axis. Y-axis. So this means it's going up $20, right? And what does the bottom number stand for? The 1? Yeah, for each year. Another way of writing that would be $20 per year. We like to write things. This makes sense to us. If you're driving, it's always miles per hour. That means how many miles in 1 hour. We could write 20 miles over 1 hour. That's the same as 20 miles per hour. So that's how we say that. When the bottom is in 1, that's when you can say, oh, it's per year, per hour, per mile, per something. Okay, but often it won't be. We're just on this example. Okay, so I think that's about it. Now the next question is, how can we predict, this would be for another day, how can we predict with this information how much money there's going to be there in 20 years, in 26 years, in 37 years? Right? You can see like, oh yeah, I could keep going 6, 147. I mean, I could keep going to 37. That would take forever. I could do that. My graph, I'm kind of out of space. I can't go any more on here. So how do we actually predict if we're, without actually writing out every single number up to 37 or making my graph super big so this actually goes up to 37? Right? And that's what the equation is going to be used for. Is, well, it's nice. We can kind of do a little bit of predicting this way, but at some point it becomes too cumbersome and too slow to predict anything. So we have to have another way, and that's what's going to be with the equations that we're going to be learning. Okay. Now, let's switch over to Desmos, and you have a new graph. Okay. Right here where it says Add Item, there's a choice for Table. Go ahead and click on that. Okay. And go ahead and type in the table that we just created. Just copy it down from the paper we just created. I just want you to see what it looks like and how to create a table, just as an exercise. Right, so let's scroll down, do a few more. Okay. So what goes first? The bold part. We got time, and we have altitude. So you write those in. So those are the labels. Go ahead and put in the units as well. What are the units for time? And what are the units for altitude? Times in hours, altitudes in feet. Okay? And again, you have to read the problem in order to get this information. If you get confused about labels and units, think about that the units you have to be able to count. You can count hours, you can count feet, okay? Or you can measure it. You can count, use a stopwatch or a ruler, something you can measure. Okay, so where does this begin? And how do you know that? Starts at 1,000 feet. Like I said before, it doesn't. The last problem says Zoe was born on. You had to figure out that was 0. This one just says starts at. So you have to figure out that that's 0. After 1 hour, where are we? And after 2 hours, where are we? Are we going? Okay, and do you think you have enough information to complete? All right. So now you figure out a pattern, you keep going. On the side here, how much is it from here to here? 100. How come it's not 100 though? Yeah, we went down, so it's negative 100. Again, it's very important that these actually come out to be somewhat the same, if not exactly the same, every single time. And the negative positive part is important. So these are all still going up by 1. Hours are counting up while the elevation is going down. So it makes sense. You're going down the mountain, so the elevation should be going down. So we're starting at 1,000 feet. And after 1 hour, we're down to 900. 2 hours, we're down to 800. And just like you're able to on the table, you're able to on the graph, just go ahead and complete it. Let's go and label this feet for units. And let's put hours down the bottom. And our change in units, the Y, we went down by, we went down 100. Technically down 100 feet. And our X's, we counted by hours for every hour. All right? So our rate of change here would be just negative 100 or negative 100 feet per hour if we had units on there. So that's what you do for the rest of this. Use Desmos. Download the app if you want to play with it. We're going to be doing a lot with this website. Okay. 1 and 2, just worry about the rest of these right now. Yeah, just do 2 through 8. I mean 3 through 8. Okay, we'll see you mañana.